Okay, so for this, our session, we'll go over the p-norm, q-norm functions, and then at the end, we'll go over how to find the mean of multiple values and the standard deviation of multiple values. Okay, so the p-norm function is used to find proportions. So, for example, if they asked us, what is the probability that they will beat this time in an event? Or what is the probability that her height is greater than this certain height? If they ask for a probability, we're going to use the p-norm function. And how the p-norm function is used is it's always, it's p-norm, and then the first parameter will be the number that we're looking for. So if we said, what is the probability that they will beat the time, and the time was 198 seconds, that would go in the first parameter. So let's say, for example, okay, let's say we have data set of heights, and let's say the mean of the height was, I don't know, 170 centimeters. We're doing it in centimeters. And then the standard deviation was, I don't know, something like 6 or something, or 7.5. Let's say that. I don't know if that makes sense, but we'll pretend that that was the mean and standard deviation of a data set of heights. And so if we wanted to find the probability that a person will have a height greater than 185 centimeters, right? We'll first put p-norm 185, and then comma, and then we do the mean, comma, and then standard deviation. So the mean was 170, right? And then standard deviation was 7.5. So we're going to run that. And so that's the probability of it being, no. Yeah, it's less than 185. Sorry, I'm so sorry. P-norm should be always less than. So if we look at a graph, let me see if I can draw. There's no pens. So if we look at a graph, P-norm is always to the left of a certain point. So if we wanted to find something greater than, we would have to do 1 minus P-norm. Yeah. So this would be, I'll type it in, probability that person will have a height of less than 185. So it will be below 185. If we wanted to find the probability of someone having a height of greater than 185, we would do 1 minus. So it'd be 1 minus p-norm. And then we'd still fill in the same numbers. Okay, so that's how we use p-norm. Okay, and yeah, so also there might be questions like, what's the probability that they'll be between two values? So for instance, we can say, what's the probability that someone will have a height of height between 175 and 185, right? To do that, we're going to do 5 and 185. So then we're going to do p-norm, and then the greater value first, 185 with the mean of 170 and a standard deviation of 7.5, minus p-norm of 175, mean of 170, and standard deviation of 7.5. So that will give us the probability that it will be between those two values. Okay? All right, so moving on to q-norm. So for Q norm, we use Q norm if we want to find the percentiles. So for example, let's see. Okay, so if we wanted to find, for example, like what percent of adults do we expect to have heights over 170, right? We want a percentage. Oh no, sorry. Sorry about that. If the question was, for instance, what is the IQ representing the 16th percentile? If it asked something about the percentile, then we're going to use the Q norm function. So the Q norm is really similar to the P norm, except for the first parameter, we're going to use the percentile. So if it asked for the 16th percentile, we would put 0.16, right? Q norm.
You said it's something about that.
So Q norm, okay. So P norm gives you a percentage, right? A proportion. But Q norm is going to give you a value. So if it's height, it's going to give you a height. If it's cholesterol, it's going to give you a cholesterol. Yeah. So for instance, if we had, this is kind of like your homework question, but if we had a cholesterol level with a mean of 99 and a standard deviation of 20, okay? And we want to find the value representing the 16th percentile, right? So what we do in this problem is we're going to do Q norm and then the percentile in decimal form. So it will be 0.16. And then the mean and the standard deviation. So all that's different is this first number. And for Q norm, it's going to be the percentile. And P norm is going to be the value that we're looking for.
Is Q norm always percentile? Or no, in decimal form?
Yes, always do it in decimal form. So if it's 99th percent, we would do 0.99. Yeah. So we run that, we get a number. And this value that we just got, the output is 79.11. That would be a value for the cholesterol level. It wouldn't be a percentage. So keep that in mind. And with the Q norm function, we can also find IQR, the interquartile range. And the interquartile range, IQR, is always, so how we find that is we do Q norm. And so the formula for IQR is Q3 minus Q1, right? Q3 is the 75th percentile and Q1 is the 25th percentile. And so with that in mind, we can do Q norm 0.75 and then the mean, standard deviation, and then we could do minus Q norm of the 25th percentile, which is 0.25, mean 99, 20. So that's how we find IQR with a Q norm function.
We also get the quartiles and the IQR from the 5num, if you remember, right?
Yeah.
This is the same thing.
Yeah, this is the same thing, except just a different way to find IQR. So yeah, any questions on that? Okay.
Well, I remember earlier during office hours, we tried to do 1 minus Q norm, and we couldn't do that. Is that because this is a value and not a percentage?
Right. Yeah. Because it doesn't make sense subtracting a value from 1 minus. Yeah. But P norm is always a proportion. So 1 is the max value of the P norm result. So that's why you can do 1 minus. Yeah. Okay. And
So
then
P normal is the probability of the values lying below that particular value. So if you have a standard normal curve, like I told you, so at whatever point you select, you take a Z score and you get the p-value corresponding to what is the probability that the data that you select lies below that value. So that is your p-norm. So it gives you the probability value in the normal distribution for that particular value of x that you input.
So for everything that we're doing right now, it's normal distribution that we're doing?
Yes.
Yeah, these functions only apply to normal because it has the norm in it. So that's another way to think about it. If it's not normal, we can't use these functions at all. Okay. Any more questions on Q-norm and P-norm? Okay. And then I'll briefly go over how to find the mean and standard deviations when we have multiple values given. So for instance, if we had a mean of 55 and we have multiple values. So for instance, we could say, actually, let's say height again. So we have a data set with heights and we have 4 people's heights. We could say, I don't know, 170, 188, 165, 159. Okay, so we have 4 heights, right? Actually, let's say we have only 3, because I think that's a lot. So we'll just say we have 3 heights given, and then the standard deviation of each height is also given. So we'll say, I don't know, 3.5, 2.4, 3.4. I don't know if these standard deviations make sense, but let's just pretend we have this data set. And we want to find the mean of the total, all the people, right? The mean height of all the people and the standard deviation of all the people that are given. So mean is we just need to add up each of the means. So the mean for the whole population would be 170 plus 188 plus 165. That would be the mean. For standard deviation, it's kind of different. For standard deviation, we have to square each of the standard deviations first. So it'd be like standard deviation 1 squared plus standard deviation 2 squared plus standard deviation 3 squared. And then at the end, we're going to square root that. Yeah. So when we square standard deviation, what are we finding? What's another name for that? The square of standard deviation. Variance. Yeah, variance. So we have to find the sum of the variances and then square root the variance to find the total standard deviation.
So you can't add standard deviations, but you can add variances. Yeah. For example, if you want to find the variance of x plus y, so that would be the variance of x plus the variance of y. But here we also assume that both of these are independent.
If it were dependent, how would that change?
Then you would have covariance, but yeah.
And if you were adding standard deviation, you'd have to square root it.
But you can't add standard deviation, you can add variance. That's the issue. So you get the variance of each of those distributions, then you add those variances, you get the total variance, and then you square root it to get the total standard deviation.
So what is this calculating? Or what are we finding just?
So you're given
Those 3 values.
Those 3 distributions.
Okay.
those are values for you, but those are distributions. Any distribution is defined by its mean and its variance. So mean and variance gives you the distribution. So you have three distributions here, and now you want to add them.
You just want to add.
Yeah.
Okay.
So if you want to find the mean for the total, pretend this is our sample, right? The total mean, the mean of the total sample, the standard deviation of the total sample over every time is what we're finding. Okay, any other questions? Okay, well that's it for today.